Ladies and gentlemen, my name is Miklós Éjes. I am a user of the Arteriograph device and software for almost 20 years. In the following, I would like to share my experiences how to use the Arteriograph device and software. Now we can see the Arteriograph software main screen. Following the process to measure a patient, we have to go to the icon of a new patient admission, or we can click on the File menu and we can click to enter a new patient. We can see the new patient window now. The yellow shadowed area must fill up because these are containing compulsory information about the patient. First, the ID number of the patient, the family name, and the first name, and then the date of the birth. And if we wish, we can enter more data, but they are not compulsory. Which is mandatory to enter is the height of the patient. And if we wish the weight of the patient, the body mass index will automatically be calculated. Also mandatory to give the arm circumference of the patient, because this will choose the diameter and the arm circumference of the upper arm, the proper cuff, and the device software helps you to choose the proper cuff, giving the size of this called M sign, medium sign. Then we can mark which arm should be used for the measurement, typically the right arm due to anatomical reasons. We can enter the gender of the patient, his or her smoking habit. If we wish, we can give the cholesterol level, and furthermore we can comment and we can provide risk profile, medication, and so on, but which I don't want to do it right now. If it is done, we will be informed that the patient data were saved successfully. Now the device and the software is ready to the measurement. We have to go to the Start icon and then click on it. We will be confirmed that really we use a proper cuff with the appropriate arm circumference. Confirming this one, the device starts to operate. Now the searching is going on for the communication port of the computer. Then this COM port will be activated, and very soon data communication will be done, and then the data reading will occur. The data will be transmitted via Bluetooth from the device to the computer real time. Here you can see the signals and the pressure curves obtained from the upper arm cuff and transmitted real time via Bluetooth to the computer software. The device first measures the blood pressure of the patient, and then, according to the actually measured blood pressure, the device first pumps back to the diastolic pressure, so pressurizing the cuff to the diastolic pressure, collecting and obtaining so-called volumetric signals. Then the device will pressurize the cuff to the so-called suprasystolic level, obtaining pure pressure signals. Now the examination is done. We can see the recorded pressure curves at the suprasystole, and here we can see the measured parameters. Here we can see the brachial systolic pressure, brachial diastolic pressure, the mean arterial pressure, the pulse pressure, which is the difference between systolic and diastolic pressure, We can see the heart rate. Let me remark that in this case the patient heart rate was a little bit higher, and we can suppose that he was suffering some kind of white coat effect. Thus, this kind of evaluation might be questionable, so we should repeat the examination in the next time or later on when the patient conditions will be more stable. Anyway, let's continuing the evaluation of the report and the measured parameters. On the left-hand side, we can see the arterial stiffness parameters. We can see the brachial augmentation index, the aortic augmentation index, which was 12.9% in this case. We can see the so-called ejection duration. This is the duration of the mechanical systole from the opening of the aortic valve and to the close of the aortic valve. Then we can see the so-called return time. This is the time in millisecond, how long and how large time is needed to travel down from the aortic root until to the aortic bifurcation, the pulse wave, and to be reflected. Then we can see the aortic pulse velocity measured. In this case, it was a little bit higher, 11.1 meter per second. Then we can see a so-called quality control of the measurement, because we measure on beat-to-beat basis of each heart cycle pulse velocity. Then the difference between the measured values are expressed in standard deviation. Obviously, the lower the difference between each heart cycle pulse velocity, the lower the standard deviation. It is acceptable and perfect until 0.7 meter per second. Between 0.7 to 1 meter per second is questionable, and if it is higher than 1 meter per second, this SD PWV will be featured in red color, meaning and referring that you should repeat the examination, and this measurement cannot be taken into account of the evaluation. The lower panel shows you the aortic systolic blood pressure value, and here you can see very nicely that how much lower physiologically the central aortic blood pressure compared to the brachial peripheral blood pressure. In this case, the peripheral systolic blood pressure was 138, and the central aortic blood pressure was only 123.9 mercury. Now we can turn of the automatic analysis S33, which was seen here, to the diastolic, so-called volumetric signal analysis. Here we can see several parameters such as diastolic reflection area, which is a complex parameter containing the pressure in the diastolic part of the pressure curve and the duration of the diastole. The longer the diastole, the higher the pressure in the diastole, the higher the diastolic reflection area. It is normal if it is higher than 40 units. Then we can see the systolic and diastolic area index. If we take into account to be 100% of the area of the whole pressure curve obtained during the diastolic pressure, the percentage of the systole in area and the diastolic area can be seen here. Ideally, it is 50-50. In this case, because of the tachycardy, the diastole was a little bit shorter, so the diastolic area index turned to be a bit lower than the systolic area index. The higher the diastolic area index and the higher the diastolic reflection area, basically the better the left coronary filling conditions. Now in the following, I would like to show you how to send the data measured via PDF format to anybody else for the remote control, or how to send it to your patient. If I click onto the send patient and I define where to store the PDF file, I can save it onto my desktop, and exporting the process very quickly, it will appear on my desktop, and then very soon the email software will come up if I install onto my computer, and then I can send it, for instance, to info cook@tensiomed.com, and then in this case, if I click it, this measurement and this PDF report has been sent to the patient or to any other further remote control for the further evaluation. Obviously, if I wish to print the report, I can click here, where I can choose the printer type, and I've selected the proper printer, and then I click OK, and then here I also can set up the printer type. If I print OK, the printing process will start, and I can print the report with the selected printer. Closing this part, we are practically ready with the examination, and in the next video, I would like to show you and to demonstrate how each parameters should be evaluated, and I would like to go through on the report on each given parameter together with its explanation and also giving their normal parameters. Thank you much for your attention, and looking forward to meeting you during the next education section.